In this lecture, we will program the logic to allow the player ship to shoot in our game. Let's use the def keyword and create a function named shoot. Inside of this function, we will create a variable named shot and set it equal to a new turtle. Then we will call the up function on shot to lift it off of the screen. We will use the goTo function to position the shot turtle, spawned at the origin, at the position of the player ship. This is so that it looks like the shot is being fired from the player ship. Then we will set the color of the shot to white. Next, we will set its shape to circle. After that, we will set its size to 0.5. Let's change the delay of the turtle to 10. Next, we will change the shot speed to 1.5. After that, we will rotate the shot left 90 degrees. Next, we will have a for loop for I in range 60. Inside of the for loop, we will call shot.forward and pass in 12. Then we will have another for loop nested inside of the first for loop, which will be for J in range lane enemies. We need to check if the shot has collided with an enemy. In a moment, we will write this function, but for now let's use an if statement and make a call to a function named isCollidedWith and pass in shot as the first argument and enemies at index J as the second argument. If a collision did not happen, we will call another function we have not written yet, showExplosion, with one argument passed in, enemies at index J dot position. Then we will hide the enemy that was destroyed using enemies at index J dot hide turtle. Then we will call shot dot hide turtle. Next, we will delete the enemy turtle by using Python's del keyword and then referencing enemies at index J. Finally, we will use the return keyword to return from this function since an enemy was hit by the shot and destroyed. Now we need to write the isCollidedWith function we referenced above. We will use the def keyword, name the function isCollidedWith, and it will take in two arguments, A and B. The job of this function will be to check if two objects have collided. It will return the value of the absolute value of A's x-coordinate minus B's x-coordinate being less than 10, and the absolute value of A's y-coordinate minus B's y-coordinate being less than 10. In other words, if the two objects are less than 10 pixels apart in the x and y direction, we will consider them to be touching. Now we need to write the other function that we called above, our showExplosion function. We will use Python's def keyword and name our function showExplosion. Our function will take in one parameter named position. Inside of this function, we will create a variable named explosion and set it equal to turtle.turtle. Then we will use the goTo function and move the explosion to the position passed into the function. Next, we will lift the explosion turtle up by calling explosion.up. Then we will set the shape of the explosion to the constant variable explosion1, which is the first in a sequence of 3 sprites for our explosion. Next, we will call time.sleep and pass in 0.1 to make the code wait for 1/10 of a second before executing. Then we will set the shape of the explosion to explosion2, the second sprite in the explosion sequence. Once again, we will wait 1/10 of a second using time.sleep. Next, we will set the shape of the explosion to explosion3, the third sprite in our explosion sequence. Then we will wait another 1/10 of a second. Next, we need to hide the explosion by using the hide turtle function. Finally, we will delete the explosion using Python's del keyword. At the bottom of the code where we listen for events, let's add a call to screen.onKey and pass in shoot as the first argument and the constant variable space as the second argument. This will allow the player to shoot when the space button is pressed. Let's run the code. As you can see, when we click the space bar, we can shoot at the enemies and destroy them. In the next lecture, we will write code to keep track of the score in our game.